Hello, I'm Monica Montegenya. I'll be presenting to you a problem that I ran through Visual Minteq on phosphorus removal from wastewater. So, a bit of a background. Wastewater almost always has phosphorus present in it. And phosphorus can get into wastewater through fertilizers that are applied in agricultural fields and get into wastewater as runoff. It can also get into wastewater from the chemicals that we use to clean our bathrooms and many other sources. So wastewater has to be treated before it is disposed into rivers and lakes, because phosphorus presents some problems when it's present in open waters. The first problem is that it encourages eutrophication. That is, this abundant growth of plants like algae or let's say seaweed, which results in oxygen depletion that affects also other life forms in water, like fish. It also makes water to smell bad and also causes turbidity, like water looks very murky. So because of these problems, wastewater has to be removed, phosphorus has to be removed from wastewater before disposal. And there are standards that have been set that when wastewater is being disposed, it has to meet those particular standards. The paper that I chose did a phosphorus removal by running a pilot membrane bioreactor to remove phosphorus from wastewater. They use iron sulfate to remove phosphorus. And so therefore, I took that problem and simulated it in Visual Minteq. My goal was to compare the efficiency of using iron sulfate, aluminum sulfate, and iron sulfate with calcium. Compare them as to which one is the most efficient in removing phosphorus from wastewater. So the inputs that I used are here on the left. The wastewater, as described in the paper, contained nitrogen, phosphorus, COD, and BOD. I ignored COD and BOD and only include nitrogen and phosphorus because Visual Minteq doesn't include BOD. So I also included carbonic acid because the actual system that's used for treating water is open to the air, so I presume that it's an open system. I used iron ferrous Fe2+ and sulfate mixed with hydrochloric acid as was described in the paper. That is 15 milligrams of HCl. So I did a pH sweep. The first scenario is here on the left, where I'm looking at iron sulfate removing phosphorus from wastewater. As we can see, there are 3 equilibrium points. The first one is at 6.5 pH and at 1.28 times 10 to the power -4 moles. This is the point that I chose to be the most appropriate, because as you see, this blue line here is a complex of iron and phosphorus, which is FeHPO4, and the green line is also another complex of iron and phosphate, which is iron HPO4, iron H2PO4. So the reason we're using iron to remove phosphate is that we want the phosphate to bond to the iron, therefore it can become insoluble and then it doesn't become active in the water, thereby causing the effects that we've talked about. So these 2 lines are of very important to us. The other forms of phosphorus that we see down here are in very low concentrations. So in this simulation, we would want our water to be at 6.5 pH. We also, the second simulation is iron sulfate with calcium. So we have 4 equilibrium points. The first one is at 1, close to 1. This makes the water very acidic. The second one is at 6.5. The third one is at close to 11, and the other one is almost 12. So again, our point of interest here is 6.5, because at pH 6.5, that's where it's close to the pH that we want our water to be. The third simulation was for iron sulfate, and it produced 3 equilibrium points. These are also the lines for the red. The red is for HPO4 -2, and the blue is for H2PO4. The iron complexes with phosphate are in green, this light green here, and in orange here. So as we can see, they're in very low concentrations. Interpreting our results, iron sulfate produced at pH 6.5 had 2 complexes, which together came up to 92% of the phosphorus. And the iron sulfate mixed with calcium also had the same result. But for aluminium sulfate, which was at pH 7, only bonded the aluminium bonded with sulfate up to only 37.5%. So from these results, we can clearly interpret that iron sulfate and iron sulfate mixed with calcium were most effective at removing phosphate compared to aluminium sulfate. And with that, we've come to the end of our presentation. Thank you very much for watching and listening.